Hello everyone, welcome back to another video. Today we're going to be having our first brain break of the year. In doing so, we're going to take a small break from problem solving and we're going to be looking at why is physics just so interesting. Additionally, we'll be looking at what is happening in physics right now, and all resources and papers are going to be quoted in the description of each video. Well, for today's video, I wanted to focus on the Event Horizon Telescope. This was recently in the news as it was able to produce a historical first. This right here, my friends, was the first image of a black hole. In order to do that, we needed to essentially create a telescope the size of the Earth. While practically unfeasible at the moment, thanks to the marvels of computational physics and several telescope dishes in various locations around the world, and the power of computational physics, we're able to create this image with the same resolution as if the whole Earth was a telescope. Now, as amazing as this image was, there was a limit to how much physics you could actually do due to the relatively lower resolution. Now, just in the past month or so, this image has been improved drastically with the power of polarization. Now, let's look at this image of the very same black hole after a polarization update. In fact, let's just take 5 seconds to marvel at it. Now, what is polarization? Remember, when an EM wave oscillates in a single plane, this means that the light is plane polarized. We tend to use polarization on sunglasses, for instance, to decrease the glare and actually increase the visible detail. So this image, the first image that we looked at was looking at light intensity only. However, the one which we have here is polarized. And look at how much more detail we can see. We can actually have a look at the individual trajectories of particles which are being swirled around and are traveling towards the event horizon. The really interesting bit is that polarization tends to be a signature of magnetic fields. So by looking at this image, researchers were able to map the electromagnetic field around a black hole and also be able to explain or at least provide a model for the acceleration of particles outside of the black hole. It is quite mysterious how black holes can produce these really large jets the size of an entire galaxy, and having a model of the strong magnetic fields can actually help us understand this much better. The team from the Event Horizon Telescope also estimates in their paper that the magnetic field will be around between 1 and 30 Gauss and the electron temperature to be a staggering 1 to 12 times 10 to the power of 10 Kelvin, which is a remarkably high temperature. Please have a look at their original paper in the description of this video. Okay guys, well, I just want to show you this image to try and put polarization into perspective and how it ties in with some cutting edge science. Hopefully you've enjoyed this. Thank you very much for watching, and I'll see you in the next video.